Alright, we are going to go over study guide 3, alcohols, ethers and related compound, part 3. In this one we are going to talk about oxidation of alcohols and how alcohols undergo oxidation to form carbonyl compounds. And basically in the first one you can see oxidation of primary alcohol to aldehyde using PCC as a mild oxidant, CH2Cl2 used as a solvent. So you can see this is primary alcohol. Under PCC it forms aldehyde, but if you use a strong one such as KMnO4, K2Cr2O7 or Na2Cr2O7, then it forms carboxylic acid directly. And secondary alcohol. In secondary alcohol, with any oxidizing agent, it will yield ketones. It won't oxidize any further. This is a secondary alcohol. Using PCC or CrO3, it forms ketone. Tertiary alcohol oxidation. It's won't oxidize with this chemical, so basically no reactions happens because of no free hydrogens available. Alright, now let's work on this problem. We need to show oxidation of 1-propanol, 2-propanol and 2-methyl 2-propanol with PCC CH2Cl2 and N-propanol with CrO3. Alright. So we have 1, 2, 3, 4, 1-propanol, PCC and CH2Cl2. You can see it forms aldehyde and this is carboxylic acid. This is 2-propanol. In PCC and CH2Cl2 it forms basically ketones. You can see here secondary alcohol forms the ketones, so that's the same one we are applying here. And CrO3 it forms ketone only. This is secondary alcohol. Alright, then we have N-propanol. No, this is 2-methyl 2-propanol, and in that one PCC and CH2Cl2 it gives no reaction. So this is tertiary. And for primary it is giving aldehyde. So you can see use that and apply the aldehyde. Under mild oxidants, under strong one it forms acid, carboxylic acid. Alright. Ether reactions. So reactions of ether with acid like HI and HBr. It's shown here. We'll quickly look at it. And ethers are relatively stable and unreactive. This is why they are often used as a solvent in reactions. Halogens, dilute acids, bases, nucleophiles have no effect on most ethers. In fact, ethers only do one reaction. They are cleaved by strong acids, and mechanism depends on the substrate. SN1 occurs faster than SN2. And let's look at an example. We need to show mechanism for the reaction between tert-butyl methyl ether and two equivalents of HBr. So this is tert-butyl methyl ether. You see these pairs of electron on this oxygen and how it reacts with HBr. That electron pull the hydrogen and that pair of electron go back to on bromine. And you can see that this is preferred due to tertiary carbocation. There is a CH3 and you can see this is happened due to tertiary carbocation. Alright. Now this Br minus 1 electrons is going to attack right there. Okay. And you can see that Br is going to substitute here. And these OH, CH3OH methanol is going to pull this hydrogen and join here and forms this charge, positive charge on this oxygen, which react with bromine. You can see the product forms here. So basically we can see the reactions. You can show the arrow and explain how these reactions happens. Mechanism for tert-butyl methyl ether and two equivalents of HBr. So we need two equivalents. So one is right here and one is right here. And the reactions occurs. This is another example that you can apply. All right. Now epoxides can be opened up by strong nucleophiles or acid that contain nucleophiles. So now we are going to talk about how ring is going to open. So the orientation depends on the substrate and the mechanism. A nucleophile will open the ring from the back side, attacking the least substituted carbon like SN2 reactions. Ring opening using acid involves two steps. First step, oxygen gets protonated. And in the second step, nucleophile attacks from the back, SN2 reactions. And with unsymmetrical epoxide, the nucleophilic attack occurs at the most substituted carbon, such like SN1. So this is epoxide, and with a strong nucleophile CH3O end up on less substituted carbon. This is more substituted carbon, this is less substituted carbon. So that way is going to go here. OH is going to go to more substituted and this will go to less substituted. Now with acid CH3O is going to attach to the most substituted carbon, which is this carbon, and OH is going to attach to the least substituted carbon. Alright. So using that, we can draw the mechanism and find out the product. We have this epoxide. Now CH3CH2O, this is negative end, which is going to attack this carbon, less substituted one. This carbon is more substituted one. So negative attack the least substituted one, and when it attacks, you can see these OCH2CH3 is substituted here, and O minus 1 here is going to pull this proton, and this electron go back to oxygen, and you can see OH join here while OCH2CH3 join here. This is the same thing we are applying to this particular situation. Let's go to next page. Now sulfide RS is analogous to ether, and thiol RSH is analogous to alcohol. Now dimethyl ether and dimethyl sulfide. And when you look at this is CH3SH and it's sp3 hybridization, that is dimethyl sulfide. This is sulfide group, this is ether group. So you can see how it's analogous to ether, sulfides, sp3 hybridization. When you look at for the properties, two dimethyl ethers next to each other, you can see negative end because of oxygen has electrons, and positive end, partial positive end. So when you have that, they form London forces and dipole-dipole forces when they are next to each other. While in the same here, this sulfide, this partial negative and partial positive, and this is same thing, partial positive, partial negative, and they form London forces and dipole-dipole forces. And dimethyl sulfide has higher boiling point. They have dipole-dipole interaction. Now you guys can explain why dimethyl sulfide has higher boiling point than the one which is oxygen. Think about the group and define that. Alright. Now nomenclature. Thiols are like named like alcohols. Instead of all, we use thiol. In SH group itself called mercapto. So all other rules are same. Instead of all, we are going to use thiol for SH group. Sulfides are named like ethers. Use sulfide instead of ethers. All other rules are the same. Alkyl thio or ethyl thio. Instead, you can write alkoxy or ethoxy. So the nomenclature is just the rule are the same. Instead of all, you are using thiol if it is SH group. And if instead of ether, we use sulfide if it is sulfide group. Alright. Now ethane thiol, we need to draw the structure. So here the structure is ethanol instead of ethane thiol. Cyclohexane all, if it is all, it's OH group, but this is thiol group. So this is SH group join here. M-mercaptobenzoic acid. So this is meta-mercapto and benzoic acid. So COOH, this is a benzoic group. This is meta position. Dimethyl ether, if it is ether, you can put O, but this is sulfide, so you can put S in between two methyl one. Methylphenyl sulfide. So you can see this methyl, this is phenyl group. Instead of ether, we can put sulfide. 3-methyl thiocyclohexene. So this is 3-methyl thiocyclohexene. So that's where you draw those structures. Okay. All right. These are synthesis of thiols. Synthesis of thiol with a strong base. And you can see the product that you get. RCH2Br2 to RCH2SH under the strong base. Synthesis of thiol from disulfide. You need zinc and HCl, where you get RSH group. This is the reactant. Synthesis of sulfide. Must be primary or secondary. And when it reacts, it goes under SN2. It gives the sulfide product. Now, oxidation of thiol to disulfide. So this thiol under I2 or Br2, it gives disulfide, RSSR, disulfide product. Now, starting with bromomethane and using reactions above indicate how would you prepare this product. Remember, you start with the reaction 1 that when you refer, this is bromo group here and under the strong base. And NABR, they are strongly get together, and here SH group join, right? So that's where you get disulfide. So that is the first one. And then under Br2 and H2O, you get disulfide. So this is kind of second step. The fourth one you can refer to get those products. These are end of study guide and the chapter problems that you can work on it at your own. Some of those summary of those oxymercuration reactions. Hydroboration we went over, SN1, SN2 hydroxylation. So you need to summarize those. Reductions of carbonyl compounds with NaBH4, LiL, H4, H3O plus. Those things you guys can summarize, make a flashcards and try to remember. We went over all of this. All right. And then I would highly suggest some of those preparations of ethers, reactions of ethers, and reactions of epoxides, ring opening ones that you guys can practice in your study guide, and preparation of thiols and thiol sulfide. So some of those reactions that you can memorize and then you can apply and try to understand it. All right.